So welcome to our short discussion panel about the AMD OpenSIL and its main, promo saying empowering the industry. I will also explain it and further in the slides. But firstly, okay, I have a dark theme, so I hope it will work well. I forgot to switch, sorry. We'll firstly talk a little bit about how generally x86 firmware, open source firmware looked throughout the history and what is the state today and Coreboot, etc. And then I will just move smoothly to AMD OpenSIL. We'll briefly describe what it is for those who don't know, and then I will show you possibly some bonus, and we'll then move to any questions and this discussion. A small disclaimer. So most of the presentation contains my own private opinions and thoughts and various speculations. Those do not belong to my employer, so that's my personal thing here. The only accurate information you may find here is mostly the historical data for Coreboot x86 sequence support that I have prepared based on Git history. So pretty much that, and everything else just aims to spark some discussion. Okay, so a little bit about how the balance of force is looking like nowadays and how it looked before between Intel and AMD in open source firmware system. So in my opinion, Intel has much more strong position and pretty much almost monopoly on x86 open source firmware. It supports various projects and frameworks like EDK2, Slim Bootloader, Coreboot. They have their silicon initialization module called Intel Firmware Support Package, in short FSP. Its presence is evidently visible in the Coreboot tree with very stable ports and silicon support. And yeah, we can see that new SoCs and microarchitectures are added year by year and pretty much do not drop too often from the tree except for old FSP1 boards. But of course, they have also their own problems, like, for example, never-ending speculative vulnerabilities appearing one after the other, and there is no end on the horizon to those issues. And yes, that's pretty much it. Now, of course, we can also say that Intel is very reluctant to open source the silicon support for servers, but that's slightly also changed in the past couple of years, but we haven't seen anything like until I don't know, maybe a year or two ago. On the contrary, AMD, as far as I know, it is not so present in open source firmware frameworks besides Coreboot. We knew that they contributed a lot back in the old days, like 2008 up to 2020, 2000 and I would say 14, 15. Then they had some short little break due to various, I would say, economical reasons, where we didn't see any new open source firmware support for new AMD platforms between 2015 and 2020, where there was the introduction of the Family 17H, so a new FSP, new kind of redesign of architecture and stuff like that. And yeah, from what I know, AMD just recently started to contribute more to EDK2. So if I am wrong here, you can feel free to correct me, but I just mainly saw AMD code in Coreboot. About the microarchitecture support and ports in Coreboot, they were mainly like fully open source in the beginning, from native implementations through Egiza and CMAX code modules. Unfortunately, they more looked like kind of dump of the code when it comes to Egiza and CMAX. That is why they were not so stable in Coreboot tree, often dropping from the main branch, where we had famous various Agisa boards dropping out of the tree because they were unmaintained. The code was poor quality, and nobody just wanted to really take care of it. But then suddenly AMD changed their mind and started releasing binary Agisa since 2014, and just released maybe 3 various processor lines, and that was it. Then we had those break, and then AMD tried to adopt the Intel FSP, creating their own FSP binary for Picasso around 2019. Of course, compliant with the Intel FSP spec, but designed for AMD processors only. And now, from like 2 or 3 years, we see that AMD tries a new approach with their OpenSIL, tries to restore its position in open source firmware ecosystem, and is back on track with fully open source silicon initialization, which is happy to see. And we'll see where will it go. So as I mentioned in the disclaimer, I went with Gitfoo and prepared some timeline how those ports look like over the time in Coreboot project. Some of the positions you may probably recognize. For example, there is a famous AMD family 10H to 15H, which lasted from 2007 to 2020 and just were dropped in Coreboot 4.12. It is a famous KGP and other boards from this family. I also pasted a couple other more significant microarchitectures here, like AMD GeoDLX, which refers to PCNG's ALIX boards. It was dropped in 4.10, for example. Then we have multiple Agisa boards dropped in 2023, along with Coreboot 4.19, due to the poor quality and unmaintained code base mainly. And these are PCNG's APU1, some Lenovo G505S, and probably other boards as well in this group. The only few that live today from the old days is basically AMD Binary PI Family 16H, which is the Step Eagle code name, which refers to the PCNG's APU2 platform, which we passionately tried to keep in the main branch and were supporting through the years since around 2016. And yes, and it happily lives to this day, although the support has been officially ended by the PCNG's company. And then we can notice this gap where there were no new platforms after 2014, and then we had the AMD Picasso in around 2019, where some first patches started to appear in Garrett. And then around 2023, in the second half of the year, first patches for AMD EPYC Genoa based on OpenSIL started appearing. And those 3 families live to this day. Of course, there are more, but they were not so important for this presentation to show. In contrary, we can see how many Intel platforms live to this day. So one of the oldest is Intel i945, which became appearing in around half of the 2008 and still lives to this day. It's one of the oldest supported North bridges in Coreboot. We have also Intel Sandy Bridge, Intel GM45, Intel Nehalem, Iron Lake, and they are in pretty good shape. Probably because they were like native ports from almost the beginning, written by mostly Coreboot developers, other than dumped from Silicon Vendor, the code dumped from Silicon Vendor, and probably that is why they keep living in the Coreboot tree up to this day. There were also some other drops, like I don't even know what these models mean. There are some integrated solutions like I82 810 or 30, I3100 or I5000 or I855. They were like appearing almost year after a year and were dropped in Coreboot 4.8 due to unfulfilling some late CBMM initialization requirement back then. And there are, of course, the Intel FSP10 platforms that were dropped in 2020 with Coreboot 4.12. They were actually impossible to implement certain requirements imposed by the Coreboot leadership. So they obviously had to be dropped. But that's pretty much it from the major drop. There were also other drops, like by some unused silicon, like I think it was Ice Lake, Quark, and other, but they're probably less significant. The main goal is to show you this disproportion of the support of the silicon on both AMD and Intel side. Yes, now it would be great to have a light dim. Maybe let me quickly switch it. Just like that. Okay. Now better. About OpenSIL, what it is. So it is like a new and fresh approach to silicon initialization for AMD platforms. And it is basically a library consisting of three static programs linked into one binary. It is designed to be simple and scalable with any x86 host firmware, but right now it only supports a handful of AMD platforms, or I would say microarchitectures. The state is right now a proof of concept, so it is not yet production use, and we can only see branches with support for particular microarchitecture. So it is not yet like generic and multi-architectural state right now. So it's still in probably in active development. So it is, what is most important is open source right from almost the start. If we just exclude the initial development that happened inside the OpenSIL consortium, then we can say it is like open source from the start. Its aim is to simplify the integration with the host firmware. So it is supposed to work with ETK2 UEFI, with Coreboot, or other host firmware frameworks that will appear in the future. So that's the main goal of this project. Okay, so the term empowering the industry comes from the blog post that was published on AMD blog in 2023 before the OCP Regional Summit, and it describes the main thought behind the AMD OpenSIL, the engineers in AMD, right? So it is supposed to empower the industry with open system firmware. But actually, what hardware can we actually use right now with this OpenSIL, right? That's a big question mark. And right now we have like a couple of AMD reference boards, like I believe it was AMD Onyx or Itamel, I believe. I made a mistake. For sure it was Onyx, it was the reference Genoa platform. And now we also have published the Turin, the SP5 socket server platforms, also on the OpenSIL repository, with probably also only the reference board from AMD being supported. Of course, there were some initiatives from other vendors like Mitak that had some proof of concept code that booted to UEFI shell on one of their OCP hardware, but that's probably the extent of what is being available in the public. Yeah, so to leverage actually the possibilities and actually the capabilities of the OpenSIL, I decided to run my own project in a free time and selected some simple, relatively cheap and quite long time supported hardware, which is the Supermicro M11 SDV. It is a small mini ITX form factor board that can be made a small server or even a small desktop, I would say. It has a BMC as a regular server, but what is, I think, most attractive is the small and very cheap AMD EPYC server processor, which is in a BGA package, so it is like a soldered down processor, and it is like pretty much energy efficient because it has much lower TDP than the regular data center servers. So the screens here is showing that I have successfully booted the Dasharo2 suite, which is the Linux distribution used by Dasharo developers, but as well as Dasharo subscribers or users in general, to deploy the firmware, perform hardware compatibilities reports, so to report any logs to developers in case of any issues, and in general it supports us with the firmware updates. Yes, so what I would like to actually to show you is how the platform is booting. So I will switch quickly to the console. I will show you how this platform boots, and I hope that nothing breaks since last time I tried it, because I haven't touched it, so I hope it will work. So here, I would just...
Font is too small, like you
can... Yeah, but give me a second. Yep. Better?
Yeah.
Right. So now I will just simply open the serial over LAN console over IPMI tool. So I will connect to my BMC for that purpose. And then I will just use the BMC GUI to power on the platform. Okay. And, sorry, session timeout. I have to log in again. All right. And let's go, power on. And you should probably hear some fans spinning in a second, or maybe not, depending whether my mic is picking it up.
Yes, we can hear it in your mic.
Sorry about that. So as you can see, it's OpenSIL booting my platform right now. It's doing some initialization. It will right now do some soft reset because I'm downcoring it to a single core right now because of certain issues I have with multiprocessor initialization right now. And yeah, now Coreboot handing over, and then we have EDK to payload. One second more. Right, yeah. And here we are in the setup. Pretty basic because it's just, standard menu. I haven't enabled any advanced feature because I didn't want to augment the build too much, and this just supposed to help me booting. The fans went silent because the BMC picked up the command sent by the Coreboot to go silent, or rather enable the intelligent fan control mode. All right. Right now I have only USB working. SATA probably would also work too, but I don't have any SATA disk connected right now. So I'm only forced to show you the USB booting. So I will go straight to booting BTS. And here we go. The system view is starting, and I will shortly be shown with the menu. And here you go. Just so that people believe me, it's really Coreboot inside. So as you can see, it is like the ROM stage starting and stuff like that. And yeah, I have some couple information printing here and other stuff. What else I can show? Probably my code, which is the most interesting. Yes, Coreboot, just some random version I put into the kconfig. Nothing fancy. As you can see, built like 4 weeks ago almost, or 3 weeks ago to be precise, right before my vacation. So I just, yeah, it was right before my vacation, just simply left in this state where it was booting and left it like that, went on a trip and issued a CFP for this presentation. All right. And as I mentioned, there is only one CPU. So as you can see, it is just one core. I still haven't figured out why my platform is actually hanging when I try to start up other threads. I'm still in the process of debugging it or finding the root cause. I also still haven't finished the PCI Express initialization, so I don't have any PCI or Express root ports enabled, just the basic SOC devices. So I'm still in the process of comparing the reference implementation in GISA to what I have in OpenSIL and what goes wrong and why I cannot have the PCI Express ports present. Despite the SATA control actually somehow got initialized by the same code, so at least some parts are working. Yeah, that's pretty much it for the demo. And going back to the slides, some closing thoughts, of course. Answering the main question in the presentation's title, whether it will empower the industry, time will show. We will see by the fruits of the work of all engaged entities. What can I say about empowering small businesses right now? I think definitely. The code base, the already present code base of OpenSIL is already a huge help when trying to implement a new microarchitecture inside this OpenSIL library. I didn't have too much work actually, rather than just simply take out some register tables, compare initialization routines, and register addresses. The whole other stuff, the API, the calling of those initialization routines and the whole flow of initialization was already there, so it was a huge help. And then also another opinion is that AMD slowly regains its position in open source firmware ecosystem. I think it's very, very good initiative from AMD with the OpenSIL. It definitely is working, although it requires some work to still reach the production state. And of course, in my opinion, they're also way ahead of Intel in terms of the CPU design and new features they add, because if we look, for example, at the confidential computing features for servers, AMD was pretty much the first one and came up with the secure and encrypted technologies, and then Intel simply followed a little bit later. So yeah, I think that this gap between 2014 and 2020 was like a good lullaby for Intel, I would say. So they just were sitting calmly on their backs and doing their stuff, not improving much, and then AMD suddenly just boom, released their new processors, added new interesting features, and and Intel had to wake up with their with some new ideas. And yeah, that's pretty much it from my side. Now I'm looking for your insights, comments. Yeah, and let's start some discussion.